In this lesson, we're asked to find the equation of a tangent line. So remember that a secant line passes through 2 points. And so if we wanted the equation of a secant line, it's a straight line, so it's y equals mx plus b. So if we were asked to find the slope, that would be your average rate of change. And then a secant line passes through 2 points. So in order to find b, we would have 2 options. So we could either use this point, let's call that x1, y1, or we could use this point, x2, y2. So they both pass through that secant line, so we could use either point. If we have a tangent line, it only passes through 1 point. So again, it is a line, it is a straight line, so we're going to find y equals mx plus b, but the slope is the instantaneous rate of change, which we will find using our interval table. So that will find our slope, and then when we want to find b, we only have 1 point we can use, and that's the point that it passes through. So in this example, we have the equation of a function, and we want to find the equation, so make sure you read the question carefully. This time we want to find the equation of the tangent line to the function at x equals -1. So if I'm looking for the instantaneous rate of change at -1, I could start at 0 and head towards it from the left side, or I could start at -2 and head towards it from the right side. I chose to start at 0 and approach it from the right side. So I'm going to do delta y over delta x. So I did these calculations separately on a piece of paper, and when I do f of 0 minus f of -1, I get a value of 0. Delta x is 1, so my instantaneous rate of change, or my rate of change at that point, or between those points, is 1. Then I did f of -0.5 minus f of -1, and I had a value of -0.1875. Delta x is 0.5, and so my rate of change was -0.375. Just to save some room, I'll just put in the values. So then I did f of -0.9 minus f of -1, and I got a value of -0.1539. Delta x is 0.1. So when I make that division, I get a rate of change of 1.539. Then I did f of -0.99 because I'm not getting a consistent answer here. So I'm going to do another increment. I did f of -0.99 minus f at -1, and I got 0.195 divided by 0.01 gives me -1.95. So now I'm getting a little bit closer and see a little bit more consistency. So I'm going to do one more interval at -0.999. When I made that calculation and subtraction, I get 1995. Delta x is 0.001, so I get 1.995. So I think that's close enough to -2. So I would say the limiting value, or the slope of the tangent line, is -2. So I know the equation of the line is y equals -2x plus b. Now remember, it only passes through 1 point, the point at which we want to find, which is at -1. So we know it passes through the point -1, and the value at -1 is 2. So we're going to put 2 in for y, -1 in for x, and we're going to find b. So b works out to be 0. So the equation of the tangent line is y equals -2x plus 0, or just y equals -2x. Previous page, and I'm just going to erase this since it's on the next page. All right. Okay, so the limiting value of the slope is -2, so m is -2. Oh, I guess I repeated this on this page. So y equals -2x plus b passes through one point at -1, 2. So I'm just repeating what I did on the previous page, since I wrote it out for some reason twice. And so we have that. So let's just go to sub that into the y equals mx plus b, passing through the point -1, 2, and then we have a slope of 0, or b of 0. All right, so let's do another one. We'll do another example. So it wants us to find the equation of the tangent at, that should say an x, equals 4. So we are given a function, 2x squared minus 3x plus 5. We want to find the equation of the tangent. So notice it says equation. So we want y equals mx plus b. So we will be using the interval table to find the slope of that tangent line, and then we're going to substitute in the point at 4. So f of 4, I've got a bit more room on this page, so I'll just write it out. F of 4 was 25. I decided to approach from the left side, so I started at 3. So f of 3 was 14. 25 minus 14 is 11. Delta x is 1. So my rate of change is 11. Then I did f of 3.5. And that worked out to be 19. So I do f of 25, or f of 4 minus f of 3.5 is 25 minus 19, which is 6. Delta x is 0.5. And then that equals 12. Then I moved a little bit closer, a little bit consistent. 11, 12 is not much difference, but I'm going to go closer. So I did 3.9, and that worked out to be 24.8702. So I did 25 minus this number, and I got 1.28 divided by 0.1 is 12.8. And then I went to 3.99. And that value is 24.987. So 25 minus this value is 0.1298 divided by 0.01 is 12.98. So I'm starting to see a good consistency here. And then I did one more at 3.999. Up to you how many intervals you do, but you want to see that consistency. Actually, this, yeah, that was 3.8702. Oh, I made a, so let me make an adjustment here. This one and this one are incorrect. Okay, at 3.9, it was 23.72. At 3.99, it was 24.8702, and then at 3.999, it was 24.987. So this difference was 0.13 divided by 0.001, worked out to be 13. So it looks like the limiting value is approximately 13. That is the slope of the tangent line. So we know the equation is y equals 13x plus b. It passes through one point at x equals 4. And at that value, the y value is 25. So we'll sub in 25 for y, 4 for x, and we're going to calculate b. And b works out to be -27. So the equation of the tangent line is 13x minus 27.